This is the second video on percentages. The first video on percentages looked at simple percentages. This video is going to look at the compounding of percentages, where a percentage change is followed by a further percentage change, followed by a further percentage change, so the change accumulates. So that's in things like appreciation or depreciation. That's where the price goes up, or the value goes up, or the amount goes up. Appreciation, or the amount or value goes down. So a house might appreciate in value if it increases in value. A car would depreciate in value with time. If you put money in the bank, you not only get interest, that gets added to your account, you get interest on the interest. That's compound interest. And lots of things in science and nature, growth and decay, are compounded. So here's an example of how we will be calculating these percents, because there's going to be quick ways to do it. Suppose there's an 8% increase, an 8% growth. So any sort of increase, 8%, your original amount is 100%. So the whole of something's 100%. If it grows by 8%, you've got 108% of the original. So 100% is the original value of something. And if it goes up in value by 8%, it's now worth 108% of its original value. That's 108 out of 100, or as a decimal, 1.08. So if you want to add on 8% to something, you multiply by 1.08. That takes you to 108% of the value. So to add on 8% is by multiplying by 1.08. That's the factor, the number, that causes an 8% increase. If something decreased by 8%, that is, from being 100% of its original, it became 92%, because it's lost 8%, it's gone down from 100% to 92%. That's 92 hundredths, 0.92. So if something has lost 8%, its new value can be found simply by multiplying by 0.92. So 1.08 has caused an 8% increase. That's 8% up from 100%. 0.92 has caused an 8% decrease. That's 8% down from 100%. And that way calculations can be carried out quite quickly. Suppose you've got a £50,000 flat and it goes up by 8% in value. So you'd find 8% and add it on. But there's a quick way to do it, and that's simply multiplying by 1.08. That adds on 8%. The next year, it falls in value by 8%. So if you multiply by 0.92, that brings the value down by 8%. So to increase by 8%, multiply by 1.08. It's now worth 54,000. The next year it goes down 8%. That's from the 54,000 it goes down 8%. So 54,000, take it down 8%, multiplying by 0.92 takes it down 8%. It's now worth 49,680. So notice it went up by 8% and then it went down by 8%, but that didn't bring it back to its £50,000. It's below £50,000. And that's because the decrease of 8% is on a bigger figure, 54,000. It's 8% of 54,000. That was only 8% of 50,000. So it's taken it down below 50,000. Now, you don't actually need to know the two figures, because you can go straight to the answer. You're simply multiplying by 1.08, multiplying by 0.92. You can do that in one go. You could just take 50,000, multiply it by 1.08, and multiply by 0.92 on the calculator, and up would come £49,680. And it wouldn't matter what way around they were multiplied. So it doesn't matter which is done first, the 1.08 or the 0.92. You'll get the same answer anyway. So the answer was simply by appreciation of 8% being 1.08 and depreciation of 8% being 0.92, and multiplying by these two factors. It takes you straight to the answer. You don't need to know the intermediate prices, value of the house. So here's one here. It's a £200,000 house. Appreciates, it goes up by 4%. That's 1.04 as a factor. Appreciates the next year by 6%. That's 1.06 the next year. And then it depreciates 5%. That's down 5%. That's 0.95. So it's 4% up from 100%, 1.04, 6% up from 100%, 1.06, 5% down from 100%, 0.95. You simply take the £200,000 house, you multiply by these three factors, up 4%, up 6%, down 5%, and there's the answer. So that makes things a lot quicker. You don't need to know the intermediate values at all. You can go straight to the answer if you use these factors correctly. So that's 4% up 1.04, 104%, 6% up 106%. That's 95%, 5% down. So that's appreciation, depreciation. About prices increasing and decreasing, and the amount of something going up or down. That happens in compound interest. That's where you put money in the bank, you pay your bank interest, and then you get money paid on the increased amount now. So you're really getting interest on the interest. So suppose you put £80,000 in the bank, pays 5% per annum, 5% per year, and you keep it in for 3 years. There's a quick way and there's a slow way. This is the slow way to do it. Take £80,000, give it an extra 5%. Now you could get 5% and add it on, or multiply by 1.05 does that in one go. Take that new amount, 84,000, and for year 2 give it 5%, 5% on the 84,000. Take that new amount for year 3, so that 88,200 gets increased by 5%, and out comes the amount you've got in the bank, £92,610 from the initial 80,000. So you've been paid interest of £12,610. Now that's quicker in that you're using the factor 1.05, but it's not as quick as it could be. You've simply multiplied by 1.05 3 times. So the quick way to do it is take the initial £80,000 and multiply it by 1.05 to the power 3. That is, you're multiplying by 1.05 3 times, and it takes you straight to the answer. You don't need to know the intermediate amounts. So it starts at 80,000, goes up 5% every year for 3 years. That's the amount in the bank. It started out at 80,000, so the amount of interest you've been paid over these 3 years is that 12,610 extra. That's the compound interest. So 92,610 is the amount in the bank. The extra amount's the compound interest, 12,610. That's after 3 years. So that's compound interest. The method here in blue is the one to use. The power button on the calculator. So click the link in the description and there's a worksheet on compound interest. It'll have the answers with it. So you're putting money in the bank at a percent per year interest for a number of years. It can be worked out with one line of calculation, that is here in blue. That's a calculation using the calculator. For most of them you have to round off the answer to the nearest pence. So the answers will come out here needing rounded off to the nearest penny. So if you click the link in the description you can get access to the worksheet and it'll have the answers. The next stage is quite important. It's how to reverse a percent increase. So what happens here is, as previously, suppose it was an 8% increase. We used the factor 1.08. If you multiply by 1.08, you're adding on 8%. Suppose you wanted to reverse that increase. You wanted to go back to the original. You would simply divide by 1.08. Now it's very important you don't find 92% here and use 0.92. There's an initial amount. You increased it by 8% through multiplying by 1.08. To get back the way, you simply divide by 1.08. And you don't use 92% here, 0.92. So here's an 8% decrease. So 8% decrease took you to 92%. That was multiplied by the factor 0.92. Suppose you wanted to reverse that decrease of 8%. You want to go back to the original. You divide by 0.92. So that's reversing the 8% decrease. So it's simply to go in one direction, you multiply by 1.08, that's cause an 8% increase. To reverse that increase, divide by the 1.08. Here it was an 8% decrease, that was by multiplying by 0.92. So to reverse it, you divide by 0.92. So here's an application. Simple questions. A flat appreciated in value by 8%. It's now worth 54,000. What was its initial value before the 8% was added on? So what's happened here is the house had a value. It was increased by 8%. That was through multiplying by 1.08, and it became 54,000. You have to figure out what the initial value was. So to reverse that, you divide by this 1.08. The 54,000 gets divided by that 1.08 and take you back to the value. It started out at £50,000. So it had been £50,000, 8% had been added on, it became £54,000, and this question was about getting back to the original price. Again, here's a car, it's depreciated by 8%, it's now worth £11,040. What was it worth initially before it depreciated? So the value, when it was multiplied by 0.92, that was decreasing its value by 8%, it became 11,040. Get back to what the initial value was, divide by that 0.92, and you're back to the original value. It started out at £12,000. It was at £12,000, it lost 8%, it became 11,040. So that's to reverse a percent increase. You simply use the factor that would cause the percent increase and divide by it. Now, quite often this is asked without the use of a calculator. That's the way you would do it if you had a calculator. If you don't have a calculator, it's a bit trickier. So here we go. VAT, value added tax on a purchase, is 20% in Britain. So 20% VAT is added at the shops. You pay it when you buy goods. So if a radio is costing you £96 in the shop, it's had VAT included on the price. So what's happened is there's been a price before VAT, excluding VAT. 20% has been added on, and this is what it's now selling at. So the value had gone up by 20%. Whatever it cost, 20% get added on. So you're paying for 120%. So you have paid 120%. You have to figure out what the initial 100% was. Now, in the calculator, you would multiply by 1.2 to add on 20%. So in the calculator, you would divide by 1.2. Now, you can do that without a calculator if you can recognise that's the same as 960 divided by 12, and 12 goes into 960 80 times. So it can be done that way without a calculator as well. They're generally not as easy as that though. What would usually be the case is you would think, I'm paying for 120%. So if I'm paying for 120%, if I divide that value by 12, I'll find out what 10% would cost. And once I know what 10% is, I can times it by 10 to make 100%. So £96 is 120%. Divide it by 12 and you get 10%. And times it by 10 and you'll get 100%. So there it is, £96 gets divided by 12, and that means you've now got what 10% is, £8. Times that up by 10 and you've got 100%. It costs £80. So that's without a calculator. You have to think, a 20% increase, this is £96 worth 120% of the original. How can I get back to an easy percent? If I divide by 12, I get to 10%, and I can times 10% up by 10 to get 100%. Here's a second example. Camera costs £120 after a 25% discount. So you're paying for just 75% of the original price. So it wants to know the price before the discount. So the value went up by 25%. You're paying for 75%. So that's equivalent to 75%. So in the calculator, you would divide by the factor 0.75, and it would give you the value. So that's what you do with a calculator. Without a calculator, you're getting a quarter off. 25% is a quarter. They're giving you a quarter off. You're only paying for 3/4. 75% you're paying for 3/4. So 75% is 3/4. You're paying for 3/4. So if you take what you're paying and divide it by 4, divide that by 3, I should say, you're finding out what 1/4 would be. So 3/4 is £120. Divide by 3 and you're finding out what 1/4 is, and then multiply by 4 and you get 4/4. That's the full original price. So £120 divided by 3, and you're finding out what a quarter would cost, and times that by 4, you've got 4/4. So that's bringing it back to fractions. So with a calculator, you think of the factor that causes the increase and you divide by that factor, and that's what's been done here. VAT added on 20%, that is the factor 1.2, adds on 20%, divide by 1.2. Without a calculator, you think that is 120%. If I divide that by 12, we get 10% and times it up by 10 to get 100%. Or in this method, with a 25% discount, you're paying for 75%, that is, you're paying for 3/4. Divide it by 3 and you'll find out what a quarter is, and times it up by 4 and you'll get 4/4. So these questions are quite common as non-calculator questions. If you click the link in the description, there's a worksheet and it's non-calculator. So the idea is it's a computer priced at £720 after a discount of 10%. You're paying for 90%. So this £720 is 90%. You can find out from that what 10% is, and then times it up by 10. So it's all non-calculator. The answers will be with the sheet, and that completes the videos on percentages. So by clicking the link in the description, there's a PDF which has previous percentage work on it from the last video, and it has an exercise here on compound interest, the 8 questions, and it's got the answers. So it's in among the other percentage stuff from the previous video. There's a separate sheet, separate PDF, which is all non-calculator. So it's without a calculator, finding the original price of something before an increase or a decrease was applied, and it'll have the answers with it. And using the same link in the description, there's a set of notes which accompanies all the number work. So it's previously looked at decimal, significant figures, scientific notation, fractions, simple percentages in the last video, and this is the compound percentages, appreciation, depreciation, and these reverse percentages, including examples shown. Hope you found the videos useful.